We're looking at solving systems of equations by substitution. So again, this is a kind of a repetition of a lot of grade 10 concepts. So we did this by substitution with linear equation, and we'll just review some of that, and then we'll extend this to solving systems of quadratic equations by substitution. So the main idea again is that we have this concept of I can replace like for like. So if something is equal to something, I can interchange those two things and still have equivalency. So for example, if A is the same as 3 or A equals 3, I can just replace A with 3 and it's equivalent to each other. So I end up with something that looks like this. Okay, so I end up with 2 times 2 times 3, okay, and I can replace that A with 3 and it makes it equivalent. So in this case here, I have x squared is exactly the same as A minus 2, so I can replace like for like. So x squared in the second expression can be replaced by an A minus 2. Okay, and that A minus 2 must then be equivalent to 20 minus y. We keep it balanced. Remember, the only rule is balance. So if I have something that's equivalent, I can replace like for like. So here I have an A plus B is equivalent to 2 minus x. So I can replace the embedded A plus B with a 2 minus x. Okay, I can do all sorts of other things, but that's the most obvious thing. So that's what I'm going to do. I'm going to say that these are equivalent. So that A plus B is replaced by the other expression, 2 minus x. Okay, because it is equivalent to A plus B, and it keeps the equation balanced. Again, that's our main rule. Here I have, well, this is a little bit harder because I don't seem to have particular equivalency, but I could solve for A here. So I can do a rearrangement. So I end up with 2x. I'm going to subtract 7 from both sides, add A to both sides. Now I have this equivalency of A, and 2x minus 7. So in the second expression over here, I can replace this A with an equivalent 2x minus 7. So I end up with 2 bracket A plus 5 equals 3x plus 1. That expression A can be replaced by 2x minus 7. And I've replaced like for like. That means that my new equation must be balanced. So same thing here. I could solve for any of these components as long as I have a like for like replacement. So in this case here, it looks like maybe the 3a and 3a here could be a like for like replacement. To do that, I need to make sure that I have an equivalent to 3a. So to do that, I would add 6b to both sides. Okay, and then I now have this like for like replacement that I could replace. So in this expression over on the right hand side, the right hand side expression can then be rewritten as 2x minus 3a equals 12, and instead of using 3a, I'm going to use an equivalent expression of 6b plus 9 minus 3x, and I've done a like for like replacement. Okay, so I've done what we call a substitution. So this is the idea then, is we're looking for equivalency, and I can substitute things that are equal.